All right, we're here with our student Rita to talk about transformations and understanding those. You ready to go?
Yeah.
Okay, great. So there's really four kinds of transformations. One is translations, rotations, reflections, and dilations, okay?
Okay.
So we'll talk about what each one of these means. Sometimes I get mixed up with the word transformation and translation because they sound so much similar. Transformation means changing, transform your shape, okay? So that's how you know that that's kind of the bucket here. And translation means that you're going to move it around, and that's how you can not get those mixed up. So let's look at a translation really quick first. Okay, the definition of a translation is sliding a shape up, down, left, and or right. Okay, so you can slide it in more than one direction. So here we have a shape A, and we're going to move this shape up and to the right to make shape A prime. That little thing that looks like an apostrophe next to the A, we call that A prime, and that's just to show us that this shape is somehow similar or compared to or came from shape A. Okay?
Okay.
So that's a translation, and what we can always ask ourselves after we make any sort of transformation, what angles have equal measure? And let me tell you what I mean by that. So here, this angle in shape A is going to be the same as this angle in shape A prime, okay? Because all you've done is kind of slide it around, okay? And this angle up in the upper right is going to be the same as the angle in the upper right here. Seems pretty simple, right?
Yeah.
You could do the same for the other two angles. And then you can also ask yourself, what sides have equal measure? So this, again, is pretty simple for a translation. You can say, well, the bottom of A is the same as the bottom of A prime. The right side of A is the same as the right side of A prime. Okay?
Okay.
All right, so pretty simple for translations. Let's go over to rotations here so that we can understand a little bit more of a complex case. So a rotation is spinning a shape by a certain number of degrees around a point. Okay, so let's take a look at an example and see what this means. So I've got the shape B here, this triangle, and I'm going to define a point that's right there. Okay? Then I'm going to spin it 90 degrees to the right, and I'm going to get that shape. Okay, can you see how we kind of spun B around that point to get B prime?
Yeah.
Okay, good. So that's what a rotation is. You could spin by 90 degrees, you could spin by 180 degrees, you can spin by any number of degrees that you want. Okay?
Okay.
So now we ask ourselves the same questions. What angles have equal measure? Well, the lower left angle of B is the same as what angle of B prime?
The top angle.
The top, right? Because that's the one that it got kind of spun up to. How about the top angle of B? Which B prime angle is it equal to?
The one on the right.
The one on the right over here, right? Okay, so you get the idea. Now, let's ask ourselves, what sides have equal measure? So B, the triangle here, this base of this triangle B, what is that going to be equally measured to for B prime?
The side that's going up and down.
Yeah, the left side here that's going up and down, right? Okay, how about this left side of B? What is it equal in length to?
The side that's on the top.
The top side of B prime, right? Okay, so why this is important is that you're going to be able to start understanding how shapes relate to one another based on whether or not they're congruent or similar. We'll get to those words in a little bit, but understanding if it's gone through a translation or rotation or one of these other transformations will help you to determine that, okay?
Okay.
All right, so now let's look at another kind of transformation called a reflection. So the definition of this is you create a mirror image on the other side of a line. Okay, so let's see what that looks like here. So I have shape C here, and I'm going to define this line that's right there, okay? And then I'm going to kind of flip C over to create a mirror image to make C prime right there. Okay, do you see that?
Yeah.
So some people think of reflection as kind of flipping, so that's fine for you to think of it like that too. You always want to know which direction you're flipping it in or reflecting. So for instance, there could have been a line down here, and that would have created a different shape down here. But our line that we're reflecting in is right here, and so we created C prime over here. Okay, now let's ask ourselves our standard questions here. What angles have equal measure? So this left angle on shape C, what is it equal in measure to?
The right angle.
The right angle on shape C prime, okay? How about the top angle?
Top angle.
The top angle, so those ones don't change. But the right angle on C is the same as which angle on C prime?
The left angle.
The bottom left angle, right? Okay. Now how about sides? So the left slanting side here of shape C is equal to which one in C prime?
The right one.
Yeah, the right
side.
slanting one, okay?
Mhm.
So you get the idea. We could go walk through the other ones too. All right, now let's look at something that's a little bit different. It's called a dilation. And what a dilation is just growing or shrinking a shape while keeping the angle measures the same. Okay, so the side lengths will be different, but the angles will be the same. Let's take a look at an example. So here is shape D. And what I'm going to do is I'm going to shrink this by 40%, and I'm going to get shape D prime. Okay, so you can see it's like a little mini-me for D, right?
Yeah.
Okay, and so let's ask ourselves the questions. What angles have equal measure? Okay, so first let's say for D here, this bottom left angle, what is it equal to in D prime?
Bottom left.
Bottom left. Upper right?
Upper.
Upper right. Okay, so
Upper
this is
right.
kind of obvious, like they're the same, right?
Yeah.
And then we can ask ourselves, though, what sides have equal measure? What do you think?
None of them.
None of them, right? Because they all shrank,
Yeah.
okay? And when you do a dilation, then you have something that's kind of different than translations, rotations, and reflections, because in those, the sides lengths all remain the same, they just might be in a different position. But in dilations, the side lengths change, and that's you're going to see how that affects congruence and similarity later, okay?
Okay.
All right, great job.
Thanks.